how does the actual implementation work? As Pedro mentioned briefly, there is something in Swift called the AST, the abstract syntax tree. This is basically the way that Swift sees your code. So when there is a piece of code, Swift kind of builds it into a tree, and using Swift syntax, which is this package by Apple, you're able to traverse this entire graph of code and decide based on the existing code how to generate new code. This is how a small piece of the graph would look. A small piece of the tree, actually. So you can see it is quite long, but we can already see a few interesting pieces. So we can already grab the name. We have the count, the name of the argument. We have the fact that it's an integer. We can grab the name of the output and put it as a return type. So really the point is that the macros transform this tree into a new piece of code based on that tree. Cool. Good morning. Thank you so much, everyone, for being here. It's amazing being here again. It's one of my favorite conferences and favorite cities in the world, so always a pleasure. Today, we are going to talk about Swift macros, which is going to be a lot of fun. But first, a quick intro to those of you that don't know me. My name is Shai. I work for a company called Monday.com, and I do a lot of open source work, especially around our Swift and combine-related projects. And I love speaking at conferences exactly like this one, and love participating in hackathons and sometimes even winning them, hopefully. Also, either an author or editor of several books. Some of them are listed here. Maybe I'm hoping you read some of them, and I hope you enjoyed them if you did. Cool. So a quick jump start to today's agenda, where we're already going to meet our first macro of the day. So on our lecture struct, we're going to attach our agenda macro and expand it, and we will get today's agenda. So first we'll start off with what are macros, how do they even work, some of the types and roles you can use when you are writing your own macros, a few tips and tricks about how you can test and debug your own macros and third-party macros, and we're gonna have some fun live coding real macro together here on stage at the middle of the talk. And we'll wrap it up with some useful open source examples that you can actually use in your project today, and share some of the limitations and downsides you should consider when adopting macros and adding them to your project. And finally, we'll wrap up with some tools and resources that you can take with you home and keep your learning. So what are macros? So at the very basic level, Apple says that macros transform your source code when you compile it, letting you avoid writing repetitive code by hand. This is like the official definition. But in essence, what it means is just that instead of writing boilerplate code over and over, you create a reusable macro once, and you put it in your code in multiple places. You can just keep reusing it over and over and over. So if you have your code with some attached macro to it, it goes through the Swift compiler and becomes this beefed up, super-powered code with the expanded macro. Let's look at a very simple example of how this works. So all of us have these kind of functions which have a completion handler. But what about async await? Will we go over all of our code and add overloads that are async throws, for example? Instead, we can write an add async macro. And the way this macro will work, it can infer the name of the method and the argument count, and it knows it's an integer, and it even knows to get the right return type from the result, and it even knows that the method needs to be throwing because there's an error in the result type. So this is really cool, and once I wrote it once, I can use it on any method in my code that has a completion handler, and I will automatically get the same method with async throws for free. This is really, really useful. But how does it even work under the hood? So there are two primary pieces, the declaration and the implementation itself of the macro. So if you have your own code that uses macros, you just put your macro and you say, I want to use this add async macro. Then the compiler goes around looking for this declaration. The declaration lives somewhere in your project. It can be either in your app or like an external module. It doesn't really matter. But it only is the definition itself. It doesn't have the implementation. Then there is the actual macro implementation. That is a macro compiler plugin, an SPM plugin, basically. And that's where the actual implementation of the macro lives in the form of a struct that conforms to a specific macro, a specific protocol based on the kind of code you want to generate. Let's focus on this declaration. So as you can see, there are a few pieces here. Let's kind of focus on the first one. So we have a few pieces here. First is the type and role. We will dive into that in the dedicated section, but you can think of a type as where can I use this macro? And you can think of a role as what kind of code can it generate. We'll see more about that later. And finally, we have a names specifier. And that kind of hints the compiler what are going to be the names of the properties or functions or whatever that we're going to generate. Many times, it's going to be arbitrary. And that means that we don't know in advance. For example, with this add async, we don't know the name of the function we're going to generate because it's based on the name of the actual function the macro is attached to. But we'll see a few examples where you can actually specify that in advance. And then the declaration itself, first we have this public macro add async, kind of look like a public function. It will usually be public because otherwise you can't access it from other modules. And it will say this is an external macro. It lives in a different module called Shai's macros. And it has this add async macro, which is the type that actually does the code generation work. Cool. How does the actual implementation work? So as Pedro mentioned briefly, there is something in Swift called the AST, the abstract syntax tree. This is basically the way that Swift sees your code. It's the way Swift structures your code. So when there is a piece of code, Swift kind of builds it into a tree. And using Swift syntax, which is packaged by Apple, you're able to traverse this entire graph of code and decide based on the existing code how to generate new code. Here's like a quick taste of how that might look. So this function from before with the add async function, with the example, this is how a small piece of the graph would look. A small piece of the tree, actually. So you can see it is quite long, but we can already see a few interesting pieces. So we can already grab the name. We have the count, the name of the argument. We have the fact that it's an integer. And we have the completion handler, which we can detect. It has a result type. We can grab the name of the output and put it as a return type. We can see that there's an error in the result type and make it a throwing function. So really the point is that the macros transform this tree into a new piece of code based on that tree. Let's dive deeper about types and roles. So there are two types. One of them you already saw, but the first one is called freestanding. As the name suggests, this is kind of like a free function. It isn't attached to any function or class or whatever, it just kind of stands in the middle of the air. The most known example of this is preview. It starts always with a hashtag. You can put SwiftUI hashtag preview everywhere, put your view inside, it will generate a bunch of code to make your preview actually work. The second kind is called an attached macro, and that's the one you saw right now. It starts with an @ sign, and it's always attached to some declaration, function, class, struct, enum, whatever. And another good example here is the observable macro that is used by the SwiftUI observation framework. And each of these has different roles. So again, types, where can we use it, freestanding or attached, and roles, what kind of code can we generate? So for freestanding, we can either generate some expression, which will return a value, or we can generate new pieces of code, new declarations, wherever that macro stands. For attached, we have 5 different ones. Peer will let you add new declarations in the same level of the original code. So for our function, we added another function exactly in the same scope that was async throw, so that's a peer macro. We have an accessor macro that lets you add getters and setters to a property. We have a member attribute macro that lets you add attributes to a type or extension. And we have member attribute, which is really useful. Lets you add new declaration, meaning new functions, classes, structs inside the type where the macro is attached to. And finally, we have an extension macro, which lets you add conformances to a type or extension the macro is attached to. We won't dive deep into those types, but basically those are the protocols you need to conform to implement each of these different types of macros. This is actually the implementation of this agenda macro I showed you earlier to print out the macro. It's a real macro that I made for this talk. So each macro implementation is kind of responsible for returning this newly generated code. So this might look like a string, but it's not actually a string. If you look at the return type, you will see it's an array of decal syntax. This is a special Swift syntax type. This is actually strictly checked by Swift syntax, so it's guaranteed to be this kind of node of code. But it's really nice that we can write it as a regular string because it's going to come in very useful, as you'll see in a moment. A few notes about how you can test, debug, and diagnose your own macros and other macros. So first you need to remember that macros are not a closed box, they're not a black box. You can always expand them and see what kind of code they generate. This is this preview macro we saw earlier. And you can see it's generating a bunch of code. For example, this preview registry, this developer tool support.preview, and it returns this content view inside the make preview method. You are entirely abstracted from that. You don't know that all of this code is being generated. But when you build your code, this is also part of your code. It's being built with it as well. But you can always see it using this expand macro functionality. When you are writing your own macros, though, you will often need to tell the user if they are doing something they're not supposed to do with the macro. And funnily and simply, the simplest way to do it is actually just throwing a Swift error, which is really convenient. So I can have my own error type and conform it to custom string convertible, give it a nice description, and then whenever I throw it from my implementation, it will be a real Swift compiler error, which is really useful. I can give like real actionable messages to the users of my macro. And we can go even deeper with what's called a diagnostic. So we can customize the severity, say it's just a warning. We can even add fix-its, which are this little fix-it button where we can replace the code with what it's supposed to be. We can add hints and notes and highlights. So it's really, really much more powerful, but also more complex, obviously. That's how it looks with a lowered warning severity. And finally, it's good to remember that macros are basically pure functions. They get an abstract syntax tree and they generate new code. So writing tests for them is really natural. It's really, really simple. It's also a really good way to make sure you're building the right thing because you can constantly check your test and see that it's outputting what you expect it to. There are two primary solutions to this today. One is part of Swift syntax. It's called assert macro expansion. And the other is by point free. It's called Swift macro testing. We are actually going to use the right one in our demo. It's really nice. It has a lot of extra features that Apple's solution doesn't have yet. So now that you know so much about macros, let's build one together. OK. I will try to raise my laptop and hope it doesn't collapse all over. So we'll see how that works out. OK, so first of all, if you ever want to create a macro, you just go to File, New, Package, and then you have Swift macro right here. This will create a new template provided by Apple. And this is actually exactly what I did here. I made a few tiny changes. First of all, I added Swift macro testing, which I mentioned, point free codes. And I also added this enum and a few instances of it. But aside from that, it's the same. You actually even get this stringify macro for free when you start this new template. What this macro does, it's actually cool. I'm going to expand it so you can see. It says it returns a tuple of the expression, and the expression is a string. So this would print the value 6 was produced by the code A plus B. And the way it works under the hood, we can go to the implementation. It just returns a tuple as a string, right, of the argument itself, which is already the computed value, and also a literal of the argument, which is the string representation of it. That's just the way the example works. But let's talk about what we are actually going to build together today. So I guess all of you have worked with enums, and you know that the most annoying part about them is that you can't do something like, is my user equal user? There is no way to do that if there is an associated value to the enum case. I can't even easily access that value to see if it exists. So there's no way to do that. So we're actually going to create a macro that fixes both of these problems. It's going to create an is case boolean for each of the enum cases. And if there is an associated value, it will also create a var with the name of the case, which is optional. We'll extract the associated value from the enum case. So that's what we're going to do today. Cool. So a few things. First of all, we start with the declaration. So this is the stringify macro declaration. We're going to write our own. It's also going to be a public macro, and we'll call it cased. It will be, oops, why is it backwards? It's going to be an external macro, and it's going to live in this same module that we had before, which is Swift heroes macros, and the type is going to be called the cased macro. Cool. But then we need to say what kind of macro it is, what type. It is going to be attached because we're attaching it to an enum. So it's going to be attached. And it's going to be a member macro because it's going to generate all of these new properties as members of the enum it's attached to. Then for named, we can actually know in advance that we're going to generate a bunch of code that is prefixed with the word is, because it's is case. So we can actually write prefixed by is, but we're also going to specify arbitrary because we don't know the name of the properties in advance. That's it for that. For the implementation, we'll make a new file. I'm going to just copy all of these imports, and I'll call it cased macro. Okay. And I'm going to make a public struct called cased macro, cased nacro, apparently. I'll fix that quickly. Cased narco. Anyways, member macro. And we'll say that we're going to write the expansion. That's what we need to conform with this protocol. It's going to be the expansion of this macro. And we're going to do two very simple things here for now. One, we're just going to return nothing for now because we want to see what's even hiding under the hood. And we're going to dump the entire declaration to see what we have to work with. Now we're going to do two final things before we can actually test this thing. First, we need in our plugin entry point to define all of the macros that exist. So we're going to add cased macro here as well. I'm going to add it to my, cool. And in our test, we'll actually write a test to see what is being generated by our macro. So we're going to say that we're going to assert macro. It's going to be of kind cased, and it's represented by this cased macro.self. And then here, something really cool, we're just going to provide a string. The string is going to be our original code. So let's put it here. Great. And then if we run our test now, something pretty cool is supposed to happen, hopefully. Okay, here we go. Testing. Okay, so it fails, but it also records the expansion of the macro automatically. So it's a really nice way. Now I can see in my test when provided this piece of code, I expect to get this expansion. I'm actually going to wrap my entire test with macro testing is recording true. This will make sure this keeps recording every time I run the test until we have a solid test and we can remove that piece of code. Cool. Now, another thing that happened is we didn't get any expansion here because we returned an empty array, but we did also have a dump of the declaration, so let's see what we got. We have this entire syntax tree. Let's put it in an easier place to look. I hope you can see it. So you can already see that at the top level we have an enum declaration syntax. This is all Swift syntax lingo, basically. We also see it has an attribute, which is our cased macro. The name of the enum is memberships. And then in the members block members, we have 4 items in the array. And those are our enum cases. Each of them is a declaration. It has elements. And the element could also have the associated value, which is this parameter clause parameters. Cool. A lot of information, but we can already see where all the information exists and how we can pull it. So first of all, we'll go to our macro. It will make sure that it's actually attached to an enum by guard let enum declaration as enum declaration syntax. If we can't cast it this way, we'll just return empty for now. Cool, and then we will want to grab all of these members, basically all of the enum cases. So let's do that. We're going to have let cases. We're going over an enum decal. Go to our members block, and then the members. And then for each of them, we will try to extract the first element, because there's only one element. Every case has just that case, basically. So we're going to cast it as, this is called an enum case declaration syntax. So we're going to do the same thing, enum case declaration syntax, and grab the first element from that. Now if we dump cases here, I'm going to call it cases decals. It's a bit nicer. Let's run it again, see what we're getting in the dump now. Cool. So now we're getting only those 4 cases, which is exactly what we expected, 4 elements. So now we can already do the first portion, which is creating our Boolean properties. The way to do this is just map over these cases. So we can just, instead of all of this, return cases decals, map, and then we get a case decal, a single declaration. And for each of them, we need a few things. First, we need the name of the case. So case decal name. But then we can't just put is and name together, because then you will get is home, and we actually want is home. So we want the actual string value. This name isn't a string, it's called a token syntax, which is this strictly typed thing that comes with Swift syntax. But we can reach in to the text name by saying I want the name.text. And now I can actually compute my camel name, where I'm going to take my first character, uppercase it, and append the rest of the string. And now I can just generate my code. I can return this new multi-line string with my new var is camel name. But now Swift won't let me do this because this isn't type checked, so I need to tell it specifically to use this raw string interpolation. And this is basically me telling Swift syntax, hey, I know what I'm doing. This is actual real code. It's going to be a Boolean. And then I can just check here if case name of the case, which is this is actually type checked, is self. I'm going to return true. And otherwise, I will return false. Let's build this. And go to our main. And let's see if I can actually use it. So if I go to my user, you'll see that I have an isUser property. And if I expand this macro, you will see that all of this code exists, and it will also be the same if I run my test one more time. As you can see, it now screenshotted basically. This also uses Swift snapshot testing, which is also another library by Point3. Cool. Now we can actually do the second part, which is grabbing the actual associated value from each enum case and exposing that as a property. So let's go back to our implementation. We actually want to have an extension on each of these enum cases, which is called an enum case element syntax. Very mouthful, I know, but we're just going to have an extension on enum case element syntax. And we're going to have our associated type on it. It's going to be a token syntax, much like the other strictly typed entities in the system. So we're going to actually reach into these parameter clause parameters and grab this name. So we have the name of the type inside the associated value. So we're going to go into parameter clause, parameters, grab the first one, and then I'm going to go into the type. And you'll see that the type is an identifier type syntax, so I have to cast it to this, otherwise I can't access the name. So I'm going to say as identifier type syntax and grab the name. Cool, so now I have something that can give me the name of the type inside the associated value. Now there's also one more gotcha that I'm no longer returning just a single piece of code. I'm actually going to return a bunch of pieces. So I'm going to swap this cases decal into a flat map, and we'll return an array of these declarations. And the first element of it is going to be the code that we already wrote. So I'm just going to paste that in and return output here. But if we have our type, which is the enum decal associated type, this is our extension, associated type. Enum decal syntax, let's see. Case decal, sorry, wrong name. So if our case does have this associated type, we can just generate code for it. So again, we're going to append a new multi-line string. And we are going to say that we have a property with the name of our case. It's going to be of type of this associated type that we just extracted. And it's going to be optional because we don't know if we are on the team case, we can't get the user, obviously. And then we're just going to guard against it. So guard case let name of the case. And then here for the value itself, I'm just going to call it element. It doesn't really matter, just any random name. So if it's not that case, we will return nil. And if it is this case, we will return name. Cool. Let's build this and run our test again. Name, let's see, I broke something. Oh, return element should be the right piece of code here. Cool. Let's run our test. Let's see what we're getting. So you see now we have this new var user. And you will also notice that it skipped it for is non-member because it doesn't have an associated value. So now if I go to my real code, I can actually ask for my user.user. And we get the actual underlying associated value that is stored here. So far, so good. Now, just two final gotchas before we wrap up this demo and macro. First, what do you think would happen? We can write a test to confirm this. If we do test none, not an enum, and we'll copy this same code, but instead here we will assert on cased on struct, not an enum. So what would happen here, and we can actually run this to confirm, is nothing. It's not going to generate anything because it doesn't have enum cases. But so this isn't doing anything wrong, but it's also not the best experience. When you put the macro, you want to actually tell the user they're doing something wrong. So as you might remember from the diagnostics section, this is where we can actually throw a real Swift error. So let's fix our macro to do just that. I'm going to add an enum error here. It's going to be a Swift error. It's going to conform to custom string convertible. It's going to have a not an enum error. We're going to provide a description for it. And if it's not an enum, we are going to return cased can only be attached to enums. And then instead of just returning an array here, we can throw error, not an enum. So now if I go and try to do this here, we'll get a real Swift compiler error immediately. But the even more fun part of this is if we go to our test and we run it again, the Swift testing framework from Point-Free not only expands the macros, it also actually expands the diagnostics. So now we know that whenever we do this kind of macro on a struct, it will output this error diagnostic. And we can actually finally remove our with macro testing because we have our first strong test which we can use and reuse. Cool. So that's one. And then there is another issue here. What happens if this case has another associated value? If we run this again, you will see that it has it in the case, but here it will still return just the first one. And the reason is that in our implementation, we are pulling this first parameter, but there can be more than one. There can be infinite amount. Well, I hope that you don't have a case with 10 of them, but it can happen, technically speaking. So we're going to actually remove this, and instead, I'm going to have an associated types. It's going to return an array of token syntaxes. It's going to do the same. You're going to go over parameter clause, parameters, but then we're going to compact map over each of these and grab this type like we did before. Cool, and now we have an array of these, and I have to coalesce into an empty array if this is optionally failing. So now I need to change this code. I'm going to take my associated types from the case declaration, but now I'm going to actually switch over the number of them. So if there's one, we're actually going to do exactly the same as we did before. I'm just going to copy paste this here. But the type now is going to be the first associated type because we know guaranteed that there is just one. Then we take care of the case of 2 or more. And default, we're not going to do anything. So let's get rid of this and decide what we do here. So what do we need to actually generate a tuple, right? We want to return a tuple of user and team as the return type and return it as a value. So we need to actually take all the associated types and put a comma in between them as a string so we can use that in our code. So we can write here tuple, go over all of our associated type, map them by taking just the text, the raw value, and then I can join them with a comma. So this will give me user, comma, team as a string. And now I can just try and let's generate some code, hopefully. Output append, multi-line string, and I'm going to have my var, which is the name of the case like before. But now instead of returning just the first, we're going to go raw tuple, because again, this is a string, and wrap it as a tuple. And it's going to be optional, because it's, again, not always going to be that case. And then I can basically use this same code. You're going to just get the element and return it. Interesting. OK, now let's build our code and see that I didn't mess anything up. And let's see what happens if I try to use it here. So I'm going to add a team here. I'm going to add another initializer here. Okay, so it's working, but it's also giving us an error and a warning. And the warning is that you could do this a few Swift versions ago, but you can no longer just return element and it will return all of the tuple values. You actually have to destructure all of the elements by hand. So it has to be let user element 1, element 2, element 3, etc., as many as you have. So let's make this final fix to our macro to make it really bulletproof. And I'm going to add this new args, which will do basically the same. Map over the associated types, I'm going to enumerate them to get indexes. And I will map and get just the index. I don't need the n element and call it e index. So I'll get E0, E1, E2, E3, etc. And then I can do the same trick of joining them with a comma. Cool. And now all I need to change are two things. Basically, here instead of element, I need to do raw args. And I'm actually also going to return it from here. Let's build it again. You see that the warning is gone. If I go here and I expand my macro, you will see that I'm getting a tuple with E0 and E1 and return it as a tuple. And this will work for an infinite amount of values. I can even destructure by going to my user.user. It will give me the user and the team. And if I run my test one final time, it will generate this same code, and I can actually finally get rid of this with macro testing because we finally finished writing our macro. Run the test one final time, and everything is green and successful. That's it. That's our macro for today. Let's go back to our slides. Cool. I'm going to use this wand for at least once in this slide. Cool. So as I promised, a few useful real-life examples that exist in GitHub today, which I thought are cool and you might want to use. So first of all is this environment values macro. It comes from wouter01/SwiftUI macros. So this is a very common case. When you want to create an environment value in SwiftUI, you have to write all this code by hand, getter, setter, a type that conforms to environment key. So here you just put environment value, and it does it for free. And you can actually see the declaration of it because it's open. And you see it's a peer macro because it's adding these struct with the environment key as a peer. And it knows it in advance that it's going to be prefixed by environment key because as you can see here, the type has underscore environment key underscore alignment, the name of the property. And it's going to add an accessor because it adds a getter and setter, and it's going to be named get and set, obviously. This is another cool macro code codable. It's not Apple codable, it's a macro code codable. It comes by SwiftUI/meta codable. You just attach this codable macro to the type. It will do the same as the regular codable, generate these initializers for you, but also gives you a ton of extra features. For example, you can use this coded at macro, which is used as a marker, and you can give a different name, like a coding key, to your specific property. So this means that instead of having to define these initializers by hand, just because you have one key that you want to change, you can just put this macro here and it will do it for you for free. And it also has a bunch of other features. I didn't write it, you don't have to clap, but I'm happy anyways. Anyways, this is like more involved. So as you can see, and I didn't mention this, you can conform to multiple types of roles. You can generate all kinds of code. Here you have extension macro because it's an extension, and you have because it conforms the type to codable, and you also have member macro because it adds all of these members to the type. And finally, I want to show an example of the freestanding macro. So Apple released not so long ago a new testing library that is probably going to replace XCTest. It's going Swift testing, and you can see the heavy use of freestanding macro based on these hashtags here. So you just do hashtag expecting, it will expand to the right code, and it takes just a regular expression. It's really, really nice. I should just trying it out. It works only with Xcode 15.3 and Swift 5.10, so take that into consideration. A few limitations and downsides you should be aware of when working with macros and writing them. So macros are purely additive. I think that's a nice thing. They can't remove your code. They can't modify it. They can only add new code. And you can always see it, as we mentioned. And they're also sandbox. So they can't make any network requests. They can't access your disk. So with those two things, they're kind of safe players in this ecosystem of Swift. The sandbox does not prevent you, though, from accessing outside information, like date, identifiers. Some developers use this information to give like random names to their types so they don't conflict with the outside world, but this is really highly discouraged. There's a built-in way to do this. You just ask the context to make a unique name for your type, and Swift syntax will give you a unique name that you can use wherever you want. So no need to access date, identifiers, etc. It will really make it hard to write tests. Finally, this is like a big one that also Pedro mentioned. Macros have a lot of dependencies. When you are pulling a macro, you are taking Swift syntax with it. Swift syntax has a huge build time issue right now. It can add a few minutes of build time. The Apple team is aware of it. I think they will be working on a solution. If you're using Twist, you can get it cached as a binary, and that will save some time. But I did use Twist Graph to show you this. I did Twist Graph just on composable architecture macros, and these are all of the packages I'm getting just to use this macro. It's a lot. It's just something that you should be aware of. The more macros you would use, then this cost diminishes because you have all of these macros using these same dependencies. If I look at on a macro level on the entire composable architecture project, you will see that there are more macro-related packages than there are non-macro-related packages, which are also, it's quite a lot, but I expect that to improve pretty soon. It's still a cost you should like take into account. I'm going to wrap up with some tools and resources for you. So first, SwiftAST Explorer. It's this awesome web tool where you can just paste in code on the left, and on the right, it's going to show you the abstract syntax tree. So you don't have to do dump declaration like I did. It's really nice. You can hover on each node. It will show you exactly why and how it analyzed it this way. So it's a really nice way to work on your macro. And of course, you can't talk about CodeGen without mentioning Sorcery. So Sorcery was built by Christoph, which is here somewhere, I hope. And yeah, I see a hand. This is really like the OG of AST-based code generation, and it was released almost 10 years ago, which is incredible. Think about it. You can basically do almost everything that Swift macro does, and some things that Swift macros can't do, with this tool that is out there for a long time. And it doesn't incur the build time penalty because it isn't required to build Swift syntax every time you compile your code. But the downside of it is that you can't use Swift to write your template. You use Stencil, and there's no great tooling to make sure you're writing the right code. That's a bit hard to debug in that sense. And also, you can't bundle it as a dependency. So if you have a macro, you can just make it a Swift package, and other people can consume it. With Twist, they would have to import your templates, and that's like a different mechanism. But it's a really awesome tool. We use it. A lot of companies I know use it. You just write a stencil template. Here, the template just counts all the types in our code base, iterates over them, and prints them. And that will just produce found to types with the name of the types in my code. If you want to keep learning, there are 2 awesome talks from the last Dub by Alex Halpin and Becca Royal Gordon. Really, really recommend them. They're super in-depth. And also, surprisingly, the Swift programming language book has a dedicated section about macros, which is really extensive, more than their usual documentation. So I should just take a look at that as well. And with that, thank you so much for your time. I hope you enjoyed this talk. And thank you. And if you have any feedback, good or bad, please share the code and share it. I would appreciate it. And if you have any questions, I'll be happy to take them. Thank you.
Thank you. You can also follow him on social media with his guitar tutorials. They are amazing if you love metal music, kind of. Thank you, Shai. So.